in the last segment, we talked about molarity, capital M, which is moles per liter, which is our segue to stoichiometry. That then leads us to segment 10. I wrote section, I meant segment. Segment 10 begins with titration, which is a specific type of solution stoichiometry. You should find a YouTube video on titration to see what this looks like in the lab and what it is by definition. To calculate, however, this is largely a dilution. However, it does depend on the mole ratio between the acid and the base. So let me show you how this looks like. What is the molarity of HCl if it requires 10.00 milliliters of 5 molar NaOH to completely neutralize a 15 ml sample of HCl? Well, first you're going to need the balanced equation. So the first thing I ask is this balanced? And the answer, of course, is yes. If you're looking for molarity, you're going to need moles per liter. Page 22. I'm going to go ahead and rewrite HCl plus NaOH yields NaCl plus H2O. Okay, so on this, I'm going to say the starting place is 10.00 milliliters times 5.00 moles of NaOH per 1,000 milliliters, and that's our definition of 5.00 molar NaOH. That's our starting point. The ending point is going to be moles of HCl. And you can see then that all you need is the mole ratio, which is 1 to 1. 1 mole HCl, 1 mole NaOH. When we do that, then we calculate that we have 0.0500 moles of HCl. That is our plan. Our plan is that to get molarity, we need moles, which we just figured out, per liter. The denominator is given in the problem because we're told that we have a 15 milliliter sample. So our molarity is 0.0500 moles per 0.01500 liter, okay, which is 3.33 molar, which is reasonable. Okay? Now on the next one, your job is to balance the equation, and you're going to see that the mole ratio is not 1 to 1. Na plus, OH minus, H plus, SO4 2 minus gives us Na2, SO4, and H2O. Then we have to balance it. 2 of these, 2 of these. And we see that our mole ratio is no longer 1 to 1. If you're solving for molarity, what is the molarity? What do you need to find? Again, you need moles per liter. The starting place will be the same. Look for the word of. 11.25 milliliters times 2.00 moles of H2SO4 per 1,000 milliliters. And you will see that that's moles So what we're looking for over here is moles of NaOH. Mole of acid to mole of base means we need the mole ratio. 1 mole H2SO4, 2 mole NaOH. Get out your calculator, and we find that we have 0.0450 moles of sodium hydroxide. Our plan again is to take 0.0450 moles of NaOH, divide by liter. 0.0450 moles, 0.00500 liter. That's our 5 milliliters converted to liters. And we get 9.00 molar NaOH. Okay? Okay, one more. Sorry it's at the end of the page, but it's not worth killing more trees to print out more lecture notes, so we're just going to go for it. Li plus, OH minus, H plus, PO4 3 minus, gives us Li3PO4, H2O, 3 of these, a 3-to-1 ratio. Okay, so I'm going to flip to the next page. And I'm going to rewrite our equation. 3LiOH plus H3PO4, Li3PO4 plus 3 waters. Okay, so we're going to assume that the phosphoric acid completely dissociates, and we're going to see that it's the same type of approach. Molarity, mole per liter, number, 4.78 milliliter, 6.00 mole H3PO4, 1,000 milliliters. Ending place is mole of lithium hydroxide. So what we need right here is the mole ratio. 1 mole H3PO4, 3 mole LiOH, and when we do that, we get 0.0860 moles. Molarity, 0.0860 mole LiOH. Sample size converted to liters. We divide and we get 5.74 molar. Okay, so at this point then, you're probably going to want to try some problems in your book or try some handout problems. All of these you want to do more problems. Okay? And if I hand this one out in class, here are some answers. If we didn't have time to check them together, here is the answer key. If we did have time to check them together, then this is just additional emphasis.